space for speak about Android security. Um, well, I will talk not only aspects that are related with the Android purely, if not about all the cycle of development when we have an Android app or any app in there related with the process, because sometimes the security is breaking because something in our old change of development is breaking. So I will start, and I like to always talk about Equifax. This is really an old case that happened, I think, in 2017, but was a big cybersecurity branch. But was in the same time that Facebook was having these problems with Cambridge Analytics, so don't have a lot of focus. But we have these statistics of the breaking, and well, Equifax says that when they have this cybersecurity break, to their system were uploaded this amount of information, 38,000 numbers of driver license and 3,200 passwords details. And also they had been some information stolen that is a really big amount. So I know, well, in some countries we have this to, when someone have stolen their information and is being creating like fake people that replace them, or they are using their credit cards or their information, and this is thanks to all these security breaks. And sometimes a break starts in our client application, so it can be our mobile application on a web browser, and then start directly in the database. So they are looking like holes that we have in the security for arrive to all this information, and I can store that information. So, and I also always say that, but we have, for example, in Europe, the GDPR, there are some laws and regulations related with security. And also if we broke something, we have these biggest security branches, we can be forced to pay a fee for that. And also in US, we are having this data child, that is something that they are creating. And I don't remember the name to other, but are basically laws that want to be equivalent to the GDPR in the US. So we need to also, as developers, take care about security, because we can have other kind of implications more than just a break and stole information. And I always say that security is a team effort. One of the myths that exists about security when we talk with people is no, this is responsibility to the security person in the company. And the question is like, we have a security expert in our companies, we have a security expert that can work with our team. And what really do a security expert? Because as usually a security expert is just a person that say what kind of things and strategy or technologies we will use for keep security in our systems, but they will not implement that. This is something that we as developers need to do. So it's a team efforts that all the parts of the system needs to stay working together and in the properly way can offer a security solution. So I will start with this. This is a case from Starbucks that happened also a long time ago. But what was doing Starbucks? They was storing the user's information in a locally way in the cell phones in plain text. Also everything, email, passwords, geolocation information. This is what they say in the official announcement, but we know that in the official things never say everything. So maybe they could still saving other sensitive information in the cell phone. So what is the problem with this is that all the data was unencrypted and was had public access. So that means that anyone can access the information. I mean, Android was developing a lot in the things of security related with this of the privacy shield that was in the US. But in the past, we have a lot of apps that can read the information that we have. Also, I remember that in one part of when I was developer, I found a lot of tutorials that say how to read the messages for your girlfriend, or how read the data for know what is happening in their cell phone. Or yeah, this sounds ridiculous, but that was what we have as examples for know to learn how to use some things. So anyone with access to that information can read that, and we can save information in a properly way. So can we solve this issue? And we can use shared preference on internal storage. So I will talk right now about shared preferences. And sometimes one thing that happened with us as developers is like we only look how to save something, and I read an article and I just copy paste what is in the article or in a Stack Overflow or what I show in a video. But we really didn't analyze what things we are copying there. So here exists something, and it's in the shared preferences. Also, I can restrict that only my app have access to that information. I can also, if I don't put this, can be public, and any other app can read also my shared preferences. So I can share things in a properly way using shared preferences and restrict the access only to my application. Um, well, now architecture components in Jetpack is creating something new that will replace shared preferences, that will be this data store. And here we will have two kinds of ways to save the information. One is the preference data stores that will be work in a similar way that shared preferences that are key pairs. Then I have a key and I have a value saving there. But I also will have a proto data store that is something with more improvements because have some type safety. So here I will define an schema for say what information I will save, and I also will define some protocols for a save and get that information. And other of the things that is happening here with data stories that they now are using Kotlin coroutines and flows for store this data in an asynchronous way in the application. So for example, the shared preferences is synchronous. So maybe we can have sometimes problems. The idea of that is have most consistently and transactionality when we are saving information in a safe environment. So continue with this. Here are, this is in alpha development. So, well, I in the past used a lot of the alpha stops, but now I wait to, we have a really release candidate of the things for use them. So I am not using, for example, now in anything in production, but also you can start a experiment with them. So we need to, you know, incorporate the libraries in our Gradle. And this is our some examples that how we can create these data store preferences. So if you see, we use this context create data here, and here also I an example that how we can read the information that we save. I don't know if someone is using, for example, the Jetpack navigation components with the data models that have something like data, mutable light data, and it's really similar to them. And also we have here how we can write a preference to data store information. So then we have here the other part, that is the product data store. So here we are including the libraries in the Gradle. And here are the other part. Now we need to have a schema for define the information that we will save in the data store. So we have a new file in the main that is called proto, and we will here will have a file defining these schemas that we will save. This is just an example for that. Exists a proto buff. This is a proto buffering language guide that we can check. I will not focus on that for see how to write this file. And here are examples that how we can basically how we can create the proto data store. So it's a little bit more complex. First, we are creating an object that will be used to serialize for define how we can serialize the information that we are saving in the data store. And this need to make match with our schema for defining the type, the information that we are saving. And then we are creating again with the context create data store like in the preference data store. But here, instead to only put the name of the data store, we also are indicating which is the way to serialize the information that we will save here. And here we have examples about how to read the information and how to write information using this serialized way. So we will continue. Then we have the internal storage. And something that happened with internal storage is by default, the files are only accessed by our app. Also, we can create files in other way, and we can establish that this restriction will be only for our application. So in that way, we are guaranteed that the information that we are saving there can be read only for our application. So the next thing is that we can use encryption too. So instead, when we are using now Kotlin as a first programming language for native applications, but we are still in the base of the Java. So we can use the Java cryptography architecture in our application that is really, really complex. So we can have ways to generate keys or key pairs. We have also a key store for save that keys. We have a Cipher for choose algorithms and encrypt information. So here is that we can use the key in a trusted zone in the cell phone. This is when we are using this key store, and we also can use asymmetric or symmetric keys for our algorithms. So here we have some of the algorithms that we can use. And there exists more because since Android 1 exists algorithms, IAS algorithms, but this is a table that is showing us what kind of keys we can use. So here is an explanation that what is this cryptography process, and basically it's like we have plain data and we will choose an algorithms and a key that can be a public key, a secret key, or a private key, or only one key, or a pair of keys, depends of the algorithms. And we will combine these two things for obtain a Cipher data that basically is our information encrypted. So here is an example that how we can read a file here using this well, these algorithms, right? So here we define our key, and then we will say that we will build an encrypted file, and we will define also which is the algorithm that we will use. We will send the key and where is the file, right? And then we will make a reading of that, and we will have the information unencrypted. And here is an example that we can write a file. And basically it's the same, just in the opposite way, that we will define the key, we will have a file, we will define how will be this encryption, then we have our content, and finally we will write that file, and in the file we will this information encrypted. So this is like a big explanation. And here we have, for example, how we can encrypt a message, right? So this is not using files, can be just for example, encrypting information that I will send in a web service, or also we can use something for decrypt that information. I found in some cases that happen a lot, for example, in the financial industry, that we need to encrypt information for send in the web services. In addition to the, for example, HTTPS, the SSL or TLS certifications, because that people want like an extra layer of security for guarantee that anything will be compromised. So I also invite you to read the official documentation, and that I am not inventing nothing. All these things that I am saying is in the documentation. Others are not there, but yeah, you can read the documentation or a lot of information. So now talk about a security myth that happened when this problem with Starbucks happened in that time. And one of the things that they say, for example, in publication is that, or created this kind of question, you know, what is better? We have an app that is easy to use or an app that is secure? Because they justify the fact to save information in not a properly way, because they want to create an application that was easy to use, was friendly to the users. And also they was trying to create a perception that they have always a permanent open session in the application. And this is why they were saving the credentials in the client side, so in the size of the applications. for always to the user can require something, they will send the credentials for know which user is. But I mean, this is also a lack of information about how things needs be to do in an application. So I am putting here that we have this protocol called OAuth. Now we have a lot of ones. We have like OpenID, we have Sound, but the most common and easy one is OAuth. OAuth is a protocol that was created in 2006. Well, starting to be being created in 2006, and the first time that was launched and released with all the rules was in 2010. So it means we have at this point like 10 years to have OAuth. The timing that happened this of Starbucks also was in around like 2017. So that means to the protocol exists, so they could use it instead to do what they did, that save information in a incorrect way. So what established it, and I will talk about bad app design that we're doing. So we have a client, we have our request resource in a REST API. So they were sending always the username and the password. This is precisely what was run. So here is an schema that how works the OAuth protocol. And we have a client app that in that case can be our Android application. So well, the protocol establishes that we will have a OAuth server. That also can be the same one in our resource servers in our REST API. Could be the same one. This is just a conceptual thing. So we will, with the client, we will request an access token, and this is our authentication process. This is when the client will send the credentials that in that case can be the username and the password. And the authentication server will verify if those credentials really are correct and exist in our system, and it's a user that have permission to access the system. So if all that is correct, they will create a token and will return the token to the client app. And then the client app will start to saving this token instead to save the credentials. So we can save the token in the shared preferences or in the new Jetpack DataStore, or in the future will be in the Jetpack DataStore instead of shared preferences, or also in a file that have only access to us. If we want to add an extra layer of security, we can encrypt that token. And on encrypt always that we will send it to the REST server. And then what happens is that we take this token and now we will send this token to the resource server, and the resource server will verify to the OAuth server if that token is a valid token, if really correspond to a user in our system, and if also that user has permission to consume the information that we want. So I mean, these things of security are things that don't happen in our applications, but are things that have an implication in our app. Because as usually when something is not working, what they say is the app is the one that is not working. And it's like, you can say, no, this is fault to the guy of the backend. So we also need to have the understanding of these things, because if we saw that something is not working properly in a backend side, we can say, you know what, this flow maybe is not correct, and we are compromising the security to the application if we don't do that in that way. So after to the OAuth server verify the token, they will reply to the resource server and say, yes, this is a properly token that have permission to consume the resource or not. And if everything is okay, they will return to the client app and say, you know, here are the information that you wanted, or can happen other scenarios that say, you know, your session is expired and you need to make a login again, or you don't have permissions to consume the information that you wanted. So here, just for a little bit fast, it's like usually we are using now JWTs. So we also have people that is agree with use JWTs or not, but it's the most common protocol for use, just for, you know. So this is an open standard that basically the people that define this protocol, they say we want to use the power of the JSONs, but add a layer of encoding in the process. So this is basically a JWT. We only have a header and a claim. So what happened with the JWTs is that anyone can take this token and can read the information of the token. So we need to combine it with a JSON Web Signature. What makes that JSON Web Signature is an algorithm that we add extra for verify to that information that we are sending in the JWT was not compromised, so because anyone can read it and can change it. So if someone changed the information in the JWT, so will not match with the signature. So we have a lot of signature, and I will say other things, but we have this. Usually, we saw in the industry this HS. And the amount of bytes, but it is just a HMAC usage with a hash algorithm. And now we have this thing of quantum computing. So I don't know if someone is reading something about quantum or studying something, but quantum computing have an algorithm that basically can broke some of the security algorithms that we have, especially like HMAC. So for example, things that are made with a hash can be broken in the easily way with a quantum algorithm. So we need to start to migrating to more complex algorithms for keep security in our systems. So we will continue. Now we will have a JWT like this. Like we have a header, we have a claims, and we have a signature for the verify this JWT. So if we explore this, we will find that and we have a header that explains which algorithm we use it and which time is. This standard don't have only JWTs or JSON Web Signature. We also have other that is JSON Web Encryption or JSON Web Keys. So we can have this structure with other different types. So this is why we define what is. And then we have the information or the claims that we want to send in a JSON format within an encoding way. And finally, we have the way that this signature was created for verify the information that is being sent in the JWT. So we have here something interesting. One of the things that happen is like, okay, so developer says, so I will send the credentials in the token, but we need to skip to put the credential in any other place that don't was the mind of the user and encrypt it in the database. So only those guys need to know which are the users, anyone else in our system. So we use here in JWTs, for example, the sub, we create an extra key for define which is the user. Sometimes I saw tokens that say ID and the number of the ID in the database for define which user is. And this is like a wrong approach. So here we have other one that are the scopes. This is not a formal key, but sometimes we can define in the token which permissions have a user if we don't want to verify those things in a programming way, if not verify directly with the token. So this of the type, I always put that one here, but sometimes we also can use JWTs in other scenarios like exchange information. So it's not only one, for example, the OAuth server, the one that will create JWTs. If not, we can create JWTs in any part of our system. So we use different libraries. And some libraries skip add the type JWT because they only handle in JWTs. And when you send that token to other part of the system that is development with other programming language, they just recognize that that token is not valid and it's just for this tag that don't have the JWT type. So we need to take care of that when we are using JWTs. And these are some registered claims that was the most used. So we have this JTI. Sometimes in the tokens we can add that only have one time for usage. So instead to save all the token in the database, for example, for verify that was used, I can create a JTI, a unique identifier, and save that identifier in the database and check if it was used or not. And this is how I know that that token was used in the past. This is an example. We have the sub that explain which identity in our system is representing this token. We also have this is, that is the issuer of the token. We can add that one when we are creating tokens in different parts of our system. So we will have an is in the Android application if we are creating tokens in the Android application for send to other parts of our system. And we also have the expiration number, and this is works when we have sessions that will expire. So this happen a lot, for example, in the financials applications, right? That we only can have 3 minutes of inactivity, and after that we need to make a login again, for example. So problem solves a lot, but here we are talking about authentication and authorization. And if someone don't have clear what is an authentication or an authorization process, the authentication process is when a user make a login. Commonly, this happen with a username and a password, but we have a lot of other options that I also will talk about later in the talk about them. And the authorization process is when we are login and we are consuming information. So in that part, we are sending the token and will be verified if we have authorization for consume those resources in our system. So here in one, we create the token, in the other one, we use the token for identify us in the system. So you can go to this website, jwt.io, if you want to read more about that or about libraries that you can include in your system, in any part of the system, or read other things. I also have this recommendation. This is a free handbook that anyone can read, and I will continue. So now what we are doing is improving our process here of communication between the client and our REST API. So we don't need to have these like bad practices, like save the credentials of the user in our client side. So now we will talk about the user credentials problem, right? And this is also something that happened with us, the developers, instead when we know that it's wrong. So one of the things that happen is that in the industry, we are offered a lot of single signing on. So only the options to make to a user, make a login user, a username, and a password. So well, this is a problem, right? Especially with the security breaks. Why? Because usually a user use always the same password in all the systems. So if a password is compromised in one system, well, hackers can try those credentials for break other systems, and they maybe will have successfully. So what do the system is, we will create rules for make to the users create super secure passwords and happen things like that, right? When we have a requirement, a uppercase, lowercase, number, and a special character. And finally, well, we have here a grandpa creating password with uppercase, 1, 2, 3, an exclamation. So this is filling the rules, but it's also a not secure password, you know, anyone can discover that. So we create a password nightmare that also people in an application are suffering. So one of the things that happen in apps is like sometimes it's complicated, write a password that have a lot of a lot of rules. So sometimes we are only watching a keyboard with only letters, and then we have other one with numbers, and in a different part we have the one with a special symbol. So can be complicated for someone write a password with all those rules. So then I have this, I never can say properly in English, me that say, well, we know we need that your password contain a uppercase letter, a number, a hieroglyph, the feather from a hawk, the blood of a unicorn. So we can create really ridiculous rules. And also the users always will find a way to create weak passwords. And sometimes happen those things in the systems that we are introducing the password and say you cannot use this password, this is the wrong password, and then you change the password, say you cannot use your last password. Happened to me a lot of in some systems. I also have detected those systems and I never try to make login. I always skip that and go directly to the recovery password. This is other important thing is like, indeed, when we are in the upside, we need to guarantee to our system have a way to recover a password. You know, I catch a job sometimes, and I was talking about those things. And when I arrive to the places, like they don't have a recovery password, um, or are 6 months, and they also still continue without a recovery password way. So we will continue. So how we can improve this for don't make a nightmare for the users? And there are a lot of improvements that we have, not only in terms of nightmare, if not also in terms to add security to the process that we will have, that not only require a username and a password, since this is something that can be compromised in a really easy way. So the people say we need to the users make login with something that they know that they have or something that they are. That is the biometric side. So we can make a single signing on, but we will require that they introduce a token, or they make, for example, a face recognition, or they make a fingerprint reading when the cell phone can permit that, for example. So we have called this a multi-factor authentication, but we also have multi-factor authentication through SMS code, since they are accessing in a mobile cell phone. We have this other one. This was a video. Just I lost the video. Yeah, I have a problem with my computer, but this is an application that is called Guardian, that is a little bit similar to what happened with WhatsApp when the QR codes reading. So you make a login in this website, but the website, instead to making go forward directly to the website, show you a QR code. So you need to go with your cell phone and scan the QR code. Then after scan the QR code, this application is listed as the application that you can handle inside the Guardian application. So you can allow or deny the access to this website in any moment that you want it there. Um, so this is an extra layer of security. And I also like to remember to, I don't know if you have these problems, but when we went to a university lab, when we are students in university or college, and you just go to check your Facebook, and then, well, you lost the notion of time, and then you go fast to your next class and you forgot to close your Facebook session, and someone always is trying to catch these victims in the lab, and they take your Facebook and may post things for you. So maybe you can remember after that you forgot to close that session and go to Guardian and say, I denied the access in that website. So you can use an application like that one, or make a implementation like the one that have Facebook, WhatsApp, for example, that you say, I want to close the session in this device, in this device, in this device, and they don't use anymore my session there. So we will continue, and we have biometrics, that this is something more complex. And when we are talking, it is not just the fingerprint or face recognition. We also have, for example, iris or retina recognition. We also have voice recognition, type recognition, and that this typing recognition is interesting. Some cell phones become with that. So they, when someone else is using the cell phone, say you are not the owner to this cell phone because you are not writing like the other one. And we also have DNA usage, but like in Etna Moda. So then we have federated identities. So we can skip all these things and use other ways to make the login. Here in the federated identities, what we are doing is using, for example, the identity provider for Facebook, for Gmail, for GitHub, but are a lot of more ones. So basically in our systems, we are not saving passwords if not someone else is doing that for us. So we have this all these social federated identities. So we need to verify based on what we want to do. Not always will be Facebook, the federated identity that we will use, or will be Twitter, or sometimes will not be GitHub, for example. Not all people have a GitHub account. We also have some enterprise federated identities, and I like that. This is some legal federated identities that exist in the Nordic countries. And I was speaking with someone that lived in Sweden, in Sweden is in English, Sweden. And he said, this is completely easy. Use the Swedish bank ID because this is the identity that we have for any government things that I want to do. If one want to make, for example, a process for require a new passport, I came and used this credential. So they have connected in the government system this federated identity way. And for people, it's really easy instead to stay creating a lot of users in any system that they need to be connected. So we have also passwordless authentication. And well, basically passwordless also means that we make to the users make logging in the application without the usage of a password. So we will replace that with other strategies. Here is someone that can be here, but not 100%. Here, what they are doing is verify, for example, first in the IP range. So we can register, for example, right now that we are in, well, that some people is doing work from home and need to access a system to the company. You can come and register the IP address that you have at your home. But also the company will verify with the health fence that you are in the place that you say that you will be working. And if you match these two things, you have access directly to the system. So that is keep the usage of credentials and also make that you can log in faster. But if any one of these is not matched, so you will require to make a multi-factor authentication and security requirement. So we can use the Touch ID. Something interesting is that our fingerprints are unique. So we can use that as identification of the user instead to require them to introduce an email address or a password. So basically, when we read a fingerprint, we can create that user as a new user if that fingerprint doesn't exist in the system, or make them log in if the fingerprint exists in the system. So we can have the SMS codes that are typically known and used. And we also have the magic links. And here I will ask, but usually all of us use Slack now. For example, Slack use magic links for we can access in the application, and is sometimes it's faster. And also if I am registering several Slack accounts, I am registered and logging directly in all the accounts that are related or associated with my email address. So we are making to the users easiest the process to identify themselves in a system. So here is a copy of a link. And then all this is part of the identity and management. I will not speak much about that, but basically the identity management is how we handling our identity users, how we provide them for information, how we catch the information about them, how we'll be handling that information, and how will we group them in groups for defined permissions, for example, what things they can access. And we have the identity and access management. Inside of the identity management, that is when we provide this process for authentication, authorization, also the identity federation. So one thing that happened is, oh, okay, so what happened if my system need all of these things? Because it's easy have a login with username and password. Basically, also you can find a library that do that for you in the system, but sometimes we need other ones. So I was working in a project that required a login with an SMS code. Why? Because we were working with a client in a country that they use a lot the cell phone number because it's really complicated found a cell phone. So you only can have one. If you want to have two, you need to justify why you will have two cell phone numbers. So for them, this is a way to guarantee that a person is a real person. And also is like a unique identifier more than a email address, for example. But the system only have the option to make login through username and password. the guys really take a lot of time in implement that. Will say that more than 6 months since that requirement was doing to implement a passwordless just with a SMS code. They and I don't know why they take a lot of time, because we have a functionality that was a SMS code verification. And for me, it's like, this is like similar, because after in the register process, when we make the SMS code verification, we get the token that authenticates us in the systems. I mean, this basically is a login. So sometimes take a lot of time implement things like that, improvements, and we can use an identity as a service. So basically, we are delegating the handling of all this identity management and identity and access management to a third-party application. Other thing that I found is sometimes developers are scary about to lose the control of the things in the system. And this is why they prefer invest like this a lot of time to finally provide a passwordless login instead to make something instantly or faster. So exists a lot of identity as a services provider. We have in all the popular clouds. We have other ones and other less popular, but also used in the industry. So you can use whatever of those ones if you want to implement things faster in an application. These are other ones. So now I will talk about other case that I call the free hamburgers. So I am from Guatemala, and here we have a lot of culture with fast food. So for example, here people eat a lot of McDonald's, a lot of Burger King, a lot of Wendy's. So I will say that also restaurants are a little bit high level than a hamburger, a McDonald's in US, for example. But in one moment, someone say, I will open a restaurant of gourmet hamburgers, and was a really, really, really success. Have a restaurant of gourmet hamburgers. So they decided to launch a loyalty application, but the loyalty application have some issues. So, well, what could go wrong here? But could go wrong something, right? And they were giving more hamburgers, but supposedly in the statistics. So again, I will ask, so what could go wrong in things in terms of security? So how is that a loyalty app can make to we can giving more hamburgers than what supposedly we will give in a loyalty program? So I will tell you what happened. So the developers to that application create a REST API that was consuming in that way. So maybe not everybody can see this at the beginning, but one of the things that happened is that we were sending from the application all the information as query params. So everything was exposed in the URL. Also, we were using the HTTP method get. So that means that everything in a URL can be watched, but also was an absence of SSL or TLS certification. That means that we were using HTTP instead of HTTPS. So anything in that communication was sending encrypted. So when we see or think about applications, say, but I cannot see that in an application, and that is true. So the people that see this is those folks that start to being hackers. And what happened with that is like they went to a place with an open Wi-Fi network with an anthem and their computer, and they start to monitoring the network. And in the network, you can see all these URLs that are being consuming for all the devices that are connected to that endpoint. So for example, these hamburgers can be in a food court in a mall, and the mall can have an open Wi-Fi for everyone connect to that Wi-Fi. So these poles can come and connect to that Wi-Fi, monitor the Wi-Fi, and see all these endpoints being consumed. So they saw basically credentials, because when we make a register, when we make a login in the loyalty app, our credentials were being traveling in that way, unencrypted, and anyone can see that in the monitoring. But they also could see the codes that was sending always that you well, that someone in the restaurant introduce to you 10 points for within a hamburger. So they detect that every single restaurant have their own code. So they collect these codes and share with the community. We have these codes where you can redeem free hamburgers. So in that I make an experiment about that. I change some hamburgers. So for example, if you redeem the 10 codes at the same time, they block your user because appear in the logs one over after other one that you were consuming, and this is something weird. But for example, if you make one code every day, that is not a normally. Also, if we use times period of times like a half an hour for reading a code, also is not detected as something abnormal in the system. uh, so for example, in one day you can start in the morning sending a code, and every half an hour, and then in the lunch you will can change a free hamburger. You never buy nothing. So that happened for that. So, well, this is why I went explaining. So why we can solve this. So the first thing is that we need to use a SSL or TLS certification. So again, this is something that happened in our backend side, but affect directly from the application because the compromise set is between the application and the backend. So we can use other things different like get, for example, post, because when you use get with query params, all the query params also travel exposed. So if I use post, for example, the query params will be travel encrypted in the HTTPS communication, but we also can change this for a JSON format. So we will have something like this, right? So thanks to the SSL or TLS certification, that information we will say travel encrypted, and anyone will can see that one. So they obviously the hamburger restaurant make a lot of changes in their system for fix this security, right? But since that, well, me and maybe other a lot of people change free hamburgers. This is other things that happen with the SSL or TLS configurations. In the past, we have some issues with the kind of certification that we use it, but Android or the Google people make a lot of improvements on there. We don't have more about those issues. But for example, since Android 8, we need to incorporate this file for define which are the networks or that our application will be trust, and we will have communications. So if you don't include that, exist some cell phones that can provide issues and never make the communications with your backend. So I recommend always add network security configurations. So initially we only need to say which domains we will use. We don't need to push the trust anchors. Sometimes we use that, especially in development, because some clients sometimes don't want to invest in pay certification, or we don't have someone that can know how to configure free certification, or they don't want to use them. So someone auto-generate a certification, and when our auto-generated certifications, so the Android detect that is not properly, so we need to include them in the Android app for both sides can trust between them. So this is one of the aspects that we need to have in mind when we are consuming services. And other thing that happened with the hamburgers is that we can add an extra layer using help fences. So what happened is, like, if the application will have all these security issues, if they will have help fences, for example, I never will could redeem codes being in my home or in my office. If not, you only can redeem codes being in the restaurant properly. So that are an extra layer of security. I used that in one implementation that was for verified building constructions. So we made to the supervisors only can fill reports when they were really in the constructions, because sometimes, well, people is not precisely good people, but they was filling the reports in their home and they never went to verify the construction. That also is a problem. So we made that with health fences. And now we have also, this is properly about Android, that is the permission requirement that was introduced since Android 6. And one of the things, this is a lot of the improvements that we have, also have a lot of implications also related with publications to applications. So first is that they split permissions in two ones. So now we will have the install time permissions and also the runtime permissions. And the idea of that is that we can explain to a user why we are requiring those permissions. So happen with things like camera usage. So I will say why I want to use your camera. You know, I will use your camera just for these things. And also now we are requiring, for example, if I use camera, I need to put in Google Play a privacy policy. So this is other of the aspects about security system, that always that we will launch something, we need to have a privacy policy related with the information that we will handle to our users, that we will collect in the applications, and what will happen when they delete their accounts or they don't use the system for a few time, or what I will do with these pictures throughout the time, for example. So when we use some sensitive permissions, we need to provide a privacy policy. Also now Google make improvements, and if you don't provide a privacy policy, they will not permit that you publish your application on Google Play. So this is basically, we saw this is what happened with the install requirements. So in the past, if you don't make any more apps for that, but I here in Guatemala have some systems that I support, for example, since Android 4.1 or others since Android 4.4. Just with an application that I am making for the Germany industry, I am supporting since Android 6. So yeah, but in the past we put all the permissions, and people when install the application just say yes, I accept, and I give permission to all those permissions. And also happens that sometimes the beginners that this is again something that I mentioned and in the past, is like when you are reading a tutorial about how to do something, and you just are copying and pasting the things that are in that tutorial, developers put a lot of permissions that sometimes their applications don't need. In that, these are sensitive permissions, so and they will not use them. So we accept everything. So now we will ask in runtime time, when a user will use these functionalities. For example, if they need to take a picture, you will say, you know, I need that you give me permissions to take use your camera, and also, for example, write information in your data storage, because I need to save the picture too. And I will use these pictures for these things. Also, for example, when we are using a geolocation. In the past, we can use, for example, geolocations process in the background. Now we have like different permissions. So we will require for use a geolocation when the app is running. But if we need use geolocation in a background, we need to also require other permission and explain today why we will do those things. So also this not only prevent that we will do like wrong things with that, also inform to the user why we are doing these things. So here is a way to define a permission. And here is for verify that we have that permission, because a user can give us permission in the application, but then they can go to the configuration to an app and remove all the permissions. So we always need to verify when we will use one permission that that permission is granted. And then this is an example that how we can require the permission to the user, and also for show an explanation if we want or not, or just say, I just need that. So you can go and read more about permissions, read the different kind of permissions that we have. Like I say, not all the permissions are required, but also when we put a permission in our manifest file, when we are development and we will use this functionality, the same Android Studio came and said, you know why, you need to ask permission for that. So they're helping a lot of us if we don't read documentation. So, and finally, for close this, because I think that we are arriving to 1 hour of talk, and I introduced this of human verification that is basically use reCAPTCHA in our applications. This is not always something that we will use, but sometimes we have some components that can be used for other application in an app, and we want to guarantee that was not something in background running our this, or we can an extra layer of security for guarantee that is someone doing that action. So we can use the reCAPTCHA. This is basically simple. We can add the dependency, and we just introduce that in the system, and this will show. So we don't need to do much. This will show the reCAPTCHA. We will click in the reCAPTCHA, and that will return to us that was a human or not. And well, this is our pictures, and well, this is like a web service, and this is something that I always put, but don't forget to include your internet permission when we are testing those things, because this is why sometimes it doesn't work. So I will submit, so I have an old version of that, but I will submit these new slides. This is my repo for this talk, also my fan page and my Twitter account if someone wants to follow me or ask me something or whatever that you wanted. And I am really glad for this space here for talk with you.
Thank you so much, Mercedes. That was so much information and so many things I didn't know about. We did have one question pop up during the presentation. Instead of switching, I think this popped up during the talk about that user loyalty app. And so Vivian asked, instead of switching all the calls to post, can we encrypt, decrypt the data send received in the query in the get call?
Well, in that you can do that, but you need to consider that have an extra cost. For example, it can be in performance or in time of response, because you need to encrypt, send the information, receive the information, and decrypt that information. So I will suggest that always use like a post approach when we are sending information. Don't need to make these extra layers of security, but we can do that perfectly. So it's not properly run, right?
Does anyone else have any questions? Vivian did say she didn't think of that in the chat, so. Okay, well, if there are no other questions, I want to thank everyone for being here today, for taking an hour out to join us for this talk. And of course, Mercedes, for preparing that and coming and sharing your knowledge and expertise with our community. Such a good talk.
Yeah, thank you. It was my pleasure, really.
So follow Mercedes on Twitter, follow us on Twitter. We'll have more events coming up soon, and we hope to see everyone at the next one. Have a great rest of your day.
Bye.